if you look at the front of your packet, we can go through and talk about this next unit that we're talking about. The packet talks about triangle similarity. It used to be its own unit, but now they've put it as a second half of congruence. So unit 5 is congruence and similarity combined. We broke that into A and B. So we're going to start with a little bit of a skills review, and there's going to be a second skills review, and I didn't assign it for homework just because of the 2-hour delay shortened the classes yesterday, but that will catch up with you eventually. Then we're going to move to talking about how we can prove that triangles are similar, and you'll notice some similar abbreviations, side, 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 angle, side, but notice we now have an angle, angle, so that'll be a little bit different. We'll have a quiz next week on those first 2 lessons. And then we're going to talk about proportions in triangles. I'm sure you've all been told about the WIDA test day activity blocks. So those will be non-academic days for you guys so that our kids that need to be WIDA tested have the opportunity to complete that test and not worry about missing content in their classes.
So do we not come to school?
You come to school. You come to school, but you are not going to go through your normal classes. In TA next Monday, you're going to sign up for which activities that you want to go to in different blocks. And then, do you remember on the PSAT day when like everybody took a test and we respected that so everybody else did something else? That's what we're doing.
We're off that day.
You guys were off that day, but today this time around they're letting it be. You guys go to activity blocks like a cell day, a social emotional learning day, where you do stuff. All the teachers have to come up with activities that we want to do, and you get to sign up for them. If you and your parents decide that your time is better spent at home, then that's a conversation with you and your parents, and they can call you in absent, and you're not missing any content that day. Does that make sense?
Yes.
How do you know if you're taking the WIDA test or not?
It comes through your email, and it's for kids that are English language learners.
Oh.
So if you're not in our ESLL program, then you're fine. Yes.
How do I choose the activities I want to do?
That's going to be the TA lesson next Monday.
Okay, done.
Any other questions about those WIDA activity block days? Your TA teacher should have already introduced this to you and told you about it last week. Didn't you get it? Some people did. Make sure if your TA teacher is one of those kinds that doesn't do the lessons, this is one you're going to want to do because you know all the cool activities are going to fill up first. So you want to make sure that your TA teacher opens up the link and lets you jump in and sign up because you want to be able to attend the activities that you want to. You know, everything from basketball in the gym to student staff volleyball game to, dog petting to, whatever floats your boat, there's going to be activities. Yes.
Is this like last time we picked activities, is it like in the Schoology course?
I'm not sure how they're going to do it, but it is similar to that where you choose activities, yes.
It's 7 hours.
It's a normal day, 7.5 hours. What else you got? Okay, yes.
Is it like the 19th and the 20th?
Yes, because it's a black and a red day. So, except for it's in the black red day. So it's 2 days in a row. So if you're not familiar with the WIDA test is a very important test that we give the kids that are English language learners, and they have to take 4 parts of the test: reading, writing, speaking, and listening. And in the past, they would spread these test dates out across a week, and the kids were pulled from class, and it was very frustrating for students because they were missing a lot of content. It was very frustrating for teachers because the kids were coming in and out, and it was hard getting the kids who were here one day and absent another to get all the tests. So what they're doing is they're pulling the kids who need to be tested And they're going to take that test, same as the kids that need to take the PSAT, SAT, took their test. And then everyone else is just gonna kind of have a activity day to let them get that testing done. Sound okay? So, check in with your TA teacher on Monday, because you're gonna wanna be a part of the group that gets to choose quickly. Make sense? Alright. So anyway, and then our test is at the end of the month. 25, 26. Okay. Moving on. You had homework, so put the packet aside. I don't want you working in the packet. I just want your homework out. When we talk about radicals, there's a couple of vocabulary words that are super important for you to know. When you have a radical, the number underneath the radical is called the radicand. The number that's invisible is going to be what we call the index. So when you're taking the square root, you're looking for two identical factors that can come out of that radical sign, and that index is a 2. There's some other invisible numbers that we have in mathematics. If you have an x, you know that's to the first, that coefficient is 1. We don't write it, but you know it's there. If you have an x to the first power, you know that that's what it is. We don't write it, but you know it's there. If I wanted to, I could put this x over 1. We don't write it, but say it with me. You know it's there. So when we talk about taking the square root, we have this index of 2. You're looking for two identical factors. A lot of times when you're dealing with radicals, you can have a cube root, a fourth root, a fifth root. Whatever this index is, that's telling you how many identical factors have to come out. Much of this is non-calculator, so you can turn your calculators over. There's no need to be pressing buttons right now, but I want you to look at 1, 2, 3, and 4. And I want to make sure that you understand how to simplify these radicals. You need to get to the point of where you know the square root of 23 squared is 23 instantaneously. That needs to make sense to you. If right now you're like, I don't get it, here's why. This square tells you that this factor is repeated, 23, root 23 times root 23. One of the properties of radicals is that if you are multiplying radicals, you can put, as long as the index matches, you can put them under the same radical sign. These are both square roots, so I can put them under one big square root sign as a product. And then therefore I have my double factor and it comes out of the radical sign. Anytime you have a square root and a square, those are inverse operations that undo each other. That would be like tying your shoes and then untying them. Those operations undo each other. When I look at number 2, there's something to be careful here, and that is this power applies to each factor to not only root 5 but also 2. So this is 2 times root 5 repeated twice. 2 times root 5 times 2 times root 5. You can collect your 2's. 2 times 2 is 4. You can collect your root 5's. Root 5 times root 5 is 5. That's why your answer there is 4 times 5, or 20. Here, the square root of 7 squared is 7. 3 times the square root of 5 can't be simplified, but these two coefficients are now 7 times 3, and they get together as 21 roots of 5. We've already talked about 2 roots of 5 squared times 3 roots of 2. So then, again, this one is 2 and 3 combined, recognizing that 20 times 3 is 60, and I end up with 60 root 2. Would you please turn to your partner, and would you please tell them one thing about these 4 problems that either is new to you or you want to make sure that you remember. Turn and talk about it. Go. All right, so when we look at 5, 6, 7, and 8, we have the same properties, but going up to a few more levels. Square root of 3 squared is 3. 3 times 2 is 6. And here I can put root 5 and root 2 under one radical sign and get 6 roots of 10. When we look at number 6, we can deal with both of our coefficients and our variables separately. When you're talking about your 80 we want to divide that out. If you look over on the board, there's two ways that you can divide 80. Some of you were taught to do divide by 2, divide by 2, divide by 2, divide by 2. So that's 4 division problems that you're going to have to do and figure out. A smarter, quicker, faster way of doing it would be knowing that 4 goes into 80, and that's going to be one of your perfect squares. So if I divide by 4, I know I can at least take the square root of 4, but I was lucky enough to get a second 4. So either way, that 4 comes out of the radical sign, and my 5 is left inside. Now if I deal with my variables, if I have 2 A's, they count as a double factor, and they can come out. So my 4 is my coefficient, my A is my variable. Let's talk about those 7 B's. They want you to picture 7 kids need to all pick a partner in PE. Somebody's going to be left out, right? That's him. Oh, I know. So we have 7 B's, and we can make 3 teams of 2, right? So each of these 3 teams of 2, 1, 2, 3, they get to come out of the radical sign, and this guy's left inside. So when we have both values and variables underneath the radical sign, that's what determines how we simplify that radical. All right, if you take a look at number 7, when I look at 45 and 60, I'm not going to bother multiplying them together because my next step is to break them down. So why would I multiply and then divide, right? So instead, I'm going to rewrite 45 as 9 times 5. Do you see 45 and 9 times 5? All right, when I look at 60, I broke it down into 20 times 3. I liked 20 because I know that 20 has a perfect square in it. Next to Lily are all my best friends. I look for them in every problem I'm at. Just like I'm not going to bother multiplying this together. I'm going to break it down and look for my best friends. I'm going to look for my perfect squares. I'm going to look for the values that I know I can break down. 9 is a perfect square. Square root of 9 is 3. 4 is a perfect square. Square root of 4 is 2. See these 2 5s? They can come out as 1. Even though one 5 came from 45 and the other 5 came from 60, it doesn't matter because when they're all under the same hat, they all count as values. The 3 is the one left without a friend. Anything that comes out is a coefficient that can be multiplied, and I get 30 roots of 3. Some of my friends went ahead and multiplied 45 times 60, and you'll get a very nice looking number. Check out it. If you multiply 45 times 60, you get 2,700, which breaks down. I immediately called that 27 and 100. There's a perfect square. When I looked at 27, I'm like, I see another perfect square because there's 9 and 3. So notice you get the same answer. Square root of 9 is 3. Square root of 100 is 10. 3 times 10 is 30. So it doesn't matter how you go about doing it. You're going to get the same answer, depending on if you want to multiply up to break down or if you want to just break those numbers down. You need to be able to tease out those factors when you're working with the radicals. Here's another example. This 3 is just a coefficient that sits outside. Root 2, root 8. Root 2 is here. Here's 8. 4 times 2. This is a perfect square. Here's a double factor. Everything comes out. 3 times 2 times 2 is 12. Turn to your partner and talk about something that is new to you or you want to make sure you remember. At this time in mathematics, it is a no-no to have a radical in the denominator. So think about something etiquette-wise that your mom or dad is on your case about all the time. Whether it's wearing nice clothes to church, whether it's not burping at the table, whether it's not eating with your fingers, whatever your parents get mad at you about. In my house, I didn't like elbows on the table. You ate with your hand, your other hand sat on your lap. And if my kids didn't have their hand on their lap, they got in trouble for it. You're allowed to eat dinner without your hand on your lap, but etiquette-wise, it's nicer to have better table manners. Are you with me on the comparison? In mathematics, we're not allowed to have a radical in the denominator because a radical is not a rational number. A radical, if you take the square root of something that's not a perfect square, it's an irrational number. And they don't want an irrational number in the bottom of the denominator. So right now, study what I've done. I've multiplied each of those values by a form of 1. I know I can undo this radical by giving him a friend. The square root of something squared is equal to that thing. So if I want to eliminate the radical down here, I'm going to multiply it by root 3 over root 3. Root 3 over root 3 is going to give me 4 roots of 3 over 3. This has the same value as this because what's inside the green is 1. And it doesn't change the value of my number. In order to follow the rules of etiquette of mathematics, we can't have a radical in the denominator. This process that we're doing it is called rationalizing. Take a look here at 10. I have this root 2 in the denominator. I'm going to multiply it by root 2 over root 2. That's going to give me 8 roots of 2 over 2. Now the interesting thing is I still have a fraction I need to simplify. So I end up with 4 times the square root of 2. 9 and 10 are what we call rationalizing the denominator. I don't have to do that in 11 and 12 because the same property that lets me multiply by putting the two things under the same hat, I can divide. As long as this index matches, I can go ahead and put 10 divided by 2 under one radical sign, which I can simplify to square root of 5. Square root of 5 is fine. I don't need to simplify it, doesn't need to be rationalized, that he's in good standing. Take a look at number 12. I can take the square root of 27 divided by 3. 27 divided by 3 is 9. Square root of 9, 3. That's one of my perfect squares. I know what to do with him. Turn to your partner and talk about what thing from this row you want to make sure that you remember or that's new to you. Turn, talk about it. Go. So all of that was algebra. All of that was stuff you should have learned last year. This is the first geometry on this worksheet. But you can understand why you need that algebra. So if I want to classify the triangle by the following side lengths, I need to learn how to work with radicals. And this is where you can use your calculator because if you need to know what's bigger, 5, 2 roots of 5, or square root of 10, I don't know for sure. The square root of 10 is a little bit more than 3. The square root of 5 is a little bit more than 2, but I can't guarantee any of those side lengths without my calculator. So I'll go ahead and I'll calculate 5 times the square, or 5, 2 roots of 5, square root of 10. 5 is the biggest. Now I put it through Pythagoras. And I can say, how does c squared compared to the sum of a squared plus b squared? In this case, c squared is smaller, therefore it's acute. Root 2, root 6, and 2 roots of 2. If you asked a middle schooler, or maybe a kindergartner, or maybe a 4th grader, which one of those values was the biggest, they would probably say the square root of 6. But 2 roots of 2 has the greatest value. So that's my c, and when I compare it to a squared plus b squared, it's the same value. So I have a right scaling triangle. Number 15, I have 3 roots of 3, and root 3. 3 roots of 3 is definitely my bigger one. So I go ahead and I start doing Pythagoras. And I get 27 compared to 12. I'm like, holy cow, that's a big difference. That's super de-duper obtuse. I wonder if it's even a triangle. Guess what? It's not. Because the sum of this value, 3, plus square root of 3 is smaller. So that's not even a triangle. So there's your geometry, but you see how you need to know how to work with the radicals in order to do that. Next up, When we are solving for x and x is in a quadratic scenario, a quadratic is where x, the graph is curved. So if Lily would please point to the green string, you can see that's going to be a quadratic. The red string above it is a linear equation. Squaring x is what gives it that curve. Because it has that curve and what goes inside is squared, there are two possible answers, both a positive and a negative one. So when we have a positive or negative, we need to make sure we remember the positives and negatives. Add 4 to each side, take the square root of each side. Here's our simplifying techniques. Divide each side by 6, take the square root. Notice if I put a positive 7 into this, I'd get a true story. If I put a negative 7 into this, I'd get a true story. 19, add 61 to each side, divide by 5. Again, if I put a positive 5 in there, I'd get a true story. If I put a negative 5 in there, I get a true story. Here's the so what, now what. This was the algebra you were supposed to walk through the door with. So if this stuff is hard for you and you don't understand it, that's on you. This is not geometry. You need to know this in order to access the geometry for this class. So if you're bored and you're sitting back and you're overwhelmed and you're done and you're frustrated, you're like, whatever, I don't care, then maybe you need to assess your placement in honors. Because if you don't know this, you should be on the edge of your seat, you should be asking questions, you should be coming to see me or email me to make sure you understand when you see these in the future. Sound okay? Yes.
Plus or minus is because in the square root it could be negative.
If I squared, just take a look at this one sentence here, Jonah. If I put positive 7 into this and squared it, I'd get 49. If I put negative 7 into this and squared it, negative 7 times negative 7 is also positive 49. There's two right answers to that. Make sense? Awesome. All right, let's get your notes out. Today we are talking about ratios, part to whole, and comparisons. The ratio is a comparison of two numbers using division. So when we look at a ratio being a comparison of two numbers using division, there's three kinds of ratios that we talk about: part to whole, part to part, and percentages. I want to ask you, if you came home to your mom and you said, "Hey Mom, I got a 40 on the midterm," what does your mom think? Bad. Bad, happy, not happy?
I said, what happened?
What should your mom ask?
What?
40 out of what? Because if you told your mom, I got a 40 out of 40 on the midterm, what's your mom think? What about 40 out of 50 on the midterm?
All right.
It's okay. What about 40% of the midterm? Not so good. So what we want to do is we want to understand this conversation about a part to a whole in reference to that denominator tells you out of what? Out of what? If I say I have 8, would you think that was a lot?
No.
I have 8 dogs at my house. That's a lot. I have $8. That's enough for Chipotle, isn't it? No, I can't even get like a taco or something. Like, can I get like a veggie or something?
The kids
So that denominator gives us our compared to what? What are we talking about? All right, our part to whole ratio is when we're talking about the part that we have over what was possible. Out of the 50 points possible, you ended up with 40. That's not that bad. A part to part ratio is one that answers to us the two parts that add together to make that whole. I got 40 questions right and 10 questions wrong. So a part to part ratio shows those two parts. Percentages represent the world's common denominator. So if you told grandma I got an 80% on my geometry test, she'd be like, well, that's pretty good. Geometry's a hard subject. I bet you're working hard. Don't grandmas always say nice things like that? Oh, good for you, sweetie pie. So an 80%, that percentage is the world's common denominator. When I go to convert your grades and enter them into SIS, I put them into percent so that everybody's clear on what you got out of 100 points. All right, some ratio words to watch out for. When you see each, out of, for every, and per, those are going to be words that you should click to you that that's dealing with some kind of rate or some kind of ratio. Here's an example. The girls' soccer team won 10 games, lost 2. The boys' soccer team won 12 games, lost 3. What I want you to do is with your partner discuss each of these 4 questions on your mark, set, go. All right, so here we go. Let's talk about this. If we talk about the girls, their wins to their losses, they won 10, they lost 2. So the ratio of their wins to the total number of games they played, they won 10 out of their 12 games. When we take a look at the boys won 12 games and they lost 3. So their wins to their games played are 12 wins to 15 losses. I like to imagine 2 friends that are each on each of the teams, and the one says, we've only lost 2 games, we're doing better than you. And the other soccer player is saying, yeah, but we've won 12 games, we're doing better than you. So it's an interesting conversation of who has the greater winning percent. So when you take the time to put it into your calculator and you look at the 10 out of the 12 games that the girls won, they have an 83% winning rate. If you take a look at the 12 games that the boys won out of their 15, then you recognize their winning percent is less, because even though they won more games, each game is worth less. And this is a crazy thing when you think about mathematics. The number in the denominator, the higher that number is, the less each piece is. Think about a plate of brownies. If I offered you half of the brownies, would you be more excited than if I offered you 1/20th of the brownies? 1/20th of the brownies, you just get a little piece. 1 out of 2 parts, half of the brownies, you get half of that whole plate. The bigger the number in the denominator, the smaller the value of the fraction. So because the boys played more games, each of these wins is worth less. Each win is 1/15. Each of the girls' wins is 1/12. So it's an interesting conversation about which team has the greater winning ratio. If you look at the boys, they're at 80% wins, and the girls are at 83.33%. So we need to be careful, and that's what percentages allows us to do. It allows us to put things into a common denominator and make it easier to compare those values. Everybody got me there? Okay. When we're dealing with rates and ratios, one of the most important things is to be able to understand the power of the units. So we're really going to watch our units. You're going to be asked to simplify ratios. There's no equal signs, so there's no cross products. All you need to be able to do is simplify these ratios. Now, do not write 1/2 here. Do not. This is not worth 1/2. A 5th grader would be like, yeah, it is. 5 divided by 10 is 1/2. But he's not reading the days and the hours. Because if I'm talking about 5 days compared to 10 hours, we all agree 5 days is a much longer amount of time. If I said that you're going to get your midterm grades in 5 days, you'd be like, 5 days? And I said, all right, maybe 10 hours. Oh, that's better. So somehow we need to simplify this ratio so that it makes sense to us. And we do it by doing what we call a unit analysis. And what I'm going to do is I'm going to multiply each fraction by a form of 1 that'll balance out the units. Put everything into the same perspective. So if I'm comparing days and hours, I'm going to write hours per days. Because I know that if I do that, my units will cancel out and I'll be left with just a value of a number. How many hours are there in every one day?
24.
There are 24 hours in one day. So when I now look at this fraction, I know that 5 times 24 is 120 divided by 10. The value of this relationship is 12. It's not 1/2. Because 5 days is 12 times 10 hours. It's 12 times bigger. So if I asked you to simplify that ratio, you need to address the difference of the units. Let's do another. Grams and kilograms. Yes,
Is there a reason the hours and days flipped?
it needs to be because that's what cancels out the unit and puts this in the right spot. Whether you're multiplying it by the numerator or the denominator. I have kilograms and grams. If I want my units to not distort my relationship, I'm going to put my kilograms and my grams in the position of where they're going to cancel out. So this grams will cancel out, this kilograms is going to cancel out. Do you know how many grams are in 1 kilogram?
1,000.
The prefix deci means 10, like a decade. The prefix centi means 100, like a century.
1,000.
Kilo is 1,000. So I know that this is worth 1,000 to 1. So when I go to multiply this out, I have 16,000 over 800. When I go to simplify those zeros, I recognize that this has a value of 20. 160 divided by 8 is 20. Turn to your partner and see if you can figure out the next one. Talk about it. Go.
How many
All right, every single yardstick is made up of 3 feet. I'm holding up a yardstick. It doesn't matter whether I describe this distance as 1 yard, the distance between the 1 yard line and the goal line in a football game, or whether I talk about this as 3 feet, because 3 feet and 1 yard are the same exact measure. Same as 24 hours in a day, 7 days in a week, 60 minutes in an hour, 60 seconds in a minute. All of those conversion factors are things that we need to be familiar with. When I put my units in offsetting positions, they cancel each other out. So this is the true relationship of these numbers. I know that 21 yards is a lot bigger than 7 feet. In fact, it's 3 times bigger. So when I go ahead and recognize that my 7 times my 21 times 3, that's going to be the true relationship between those values in my numerator and denominator. I'm not going to multiply and then divide. What I'm going to do instead is divide then multiply, because 7 comes out of 7 once and out of 21 3 times, giving me a value of 1/9. Somebody asks me to simplify that ratio. Why don't you compare 7 feet to 21 yards? It's a 1 to 9 story. 21 yards is 9 times bigger than 7 feet. So the comic here, in case you never heard of this joke, this little American's like, hey, to convert from miles to feet, you just have to remember 5 tomatoes. It sounds like 5280, and there are 5,280 feet in 1 mile. Isn't that cool? And this edgy European chick says, yeah, but to convert from kilometers to meters, you just have to remember 1,000, because our system wasn't invented by a drunken lobster. So that's their joke. But we'll go ahead and we'll take it because my miles is gonna go here and my feet is gonna go here. If I'm comparing this many miles to this many feet, I need to know that there are 5,280 feet for every 1 mile. So when I go to simplify this ratio, if you want to grab your calculator, you can do 2 times 5,280 and you get 10,560. Divide by 2,640. Oops, something's wrong. What did I mess up?
2640.
2640. We like that better, huh?
You
No?
provided the one.
What the answer?
Start over again. 10,560 divided by 2,640. Did I get it right now?
Yes.
Bravo. Brady can post Mario. So simplifying these ratios is going to be something that could get you. So make sure you do some practice and that you understand how to do it. All right, moving on to your next page. Moving on to talking about proportions. Proportions are when we have two ratios set equal to each other. There's two parts of proportions. I don't know if you've heard of this before, but every proportion has means and extremes. Our extremes are our first and last terms. Our means are our middle terms. So if you have 1, 2, 3, 4 terms, the first and the last are our extremes, and the middle two are our means. Proportions have some pretty cool properties that you can use when you're solving. The most common one that I know you've seen before is going to be cross products. I know you've seen that if you take the product of each of the means and the product of the extremes, then you end up with them being equal to each other. This doesn't have to be so complicated because even though you might think cross products or the butterfly method or whatever you want to call it, it's really just an application of the multiplicative property of equality of MPO, because you're multiplying each side by D and then each side by B and having them cancel out. Our next property is going to be the reciprocal property. And if you look at, God bless you, each of these properties, my reciprocal property says if you've got two ratios set equal to each other and you turn them upside down, flip them, give you their reciprocals, it's not going to be the same relationship, but it'll still be true. So if I took A over B equals C over D and see how I flip it? A and C are now in the denominator. Sometimes it's easier to use with real numbers. If 2 divided by 3 is the same as 4 divided by 6, then 3 divided by 2 is going to be the same as 6 divided by 4. Not the same relationship. 2/3 is less than 1, 3/2 is bigger, but an equal relationship. Our next property is called our means and extremes property. And that means that I can flip-flop my means or my extremes. Take a minute here and look at this. How if I have A over C, if A over B is equal to B over C, then see how I flip-flopped B and C? If I wanted to, I could flip-flop D and A. If 2/3 is equal to 4/6, then 2 over 4 has the same value as 3 over 6. And I can flip my means. The most important thing is each one of these properties can be justified by cross products. Every single one of these things look at, and no matter what, you're multiplying 2 and 6, and you're multiplying 4 and 3. No matter what, you're multiplying 2 and 6, and 4 and 3. No matter what, 2 and 6, 2 and 6, 2 and 6. You're multiplying 4 and 3, 4 and 3, 4 and 3. So no matter how you flip your proportions around, you're justifying it. right, our next property of proportions is called adding one. And when we talk about adding one, we need to think about these fractions before we combined our like terms. So if I have a plus b all over b, I can split it up into that, a over b plus b over b. If I have c plus d all over d, I can rewrite this like this. Notice each of these is worth 1. So my APO, additional property of equality, says you can add 1 to each side of a fraction, and it has the same value. We've seen extended ratios before, and that's just where we have ratios of more than 2 terms. We've done it when we've had like side lengths for the perimeter, angle measures for the triangle sum theorem. We'll see an example of that in a minute. All right, something that might be new to you is something that's called the geometric mean. And when we find the geometric mean, we're finding a value so that we can find the square root of their product. So if you look at this template for the geometric mean, we're looking for a proportion where x exists in the denominator of one fraction and the numerator of the other. You already had an arithmetic mean when you did midpoint. You found the average of the coordinates. Geometric mean is different because you're going to multiply and then take the square root. If I wanted to make this as square as I could, and I needed to know the measurements, I would multiply these two values together, a times b, and take the square root. And that would be the size that this box would need to be so that I had the exact same amount of length on each side. All right, let's do some. All right, you've seen this problem before. The measures of the angles in a triangle are in the extended ratio of 1 to 2 to 3. So I know I'm talking about measures of angles, and I know that the sum of all the angles in a triangle is 180 degrees. Don't mix up your angles and your sides. I know that 1 plus 2 plus 3 does not equal 180. So if I want to solve for that, that's not going to help me. But what I do know is that they are in this ratio. So that means that I definitely simplified by some value of x, some factor that I can figure out. What's 1x plus 2x plus 3x?
6x.
Definitely 6x. Divide by 6. X is equal to 30. Therefore, this angle measure is 30 degrees. This angle measure is 60 degrees. And this angle measure is 90 degrees. Are those angles in the relationship of 1 to 2 to 3? Yeah. 30, 60, 90. Does have a 1 to 2 to 3 story, for sure. All right, let's take a look at number 2. When we're finding a geometric mean, we're going to set up this template. Find the geometric mean of 4 and 9. You are looking for some number that exists in the denominator of one fraction and the numerator of another. That value that splits 4 and 9 is what you need to be finding. So when you go to look for it, you know that x times x is x squared. 4 times 9 is 36. So when you take the square root, you know you've got 6. The geometric mean is always going to be the positive value, never the negative. If it's a geometric mean problem, you can set up your template, but that doesn't mean that X goes in that spot. If you read number 3 carefully, it tells you that 10 is your geometric mean between 4 and some number X. There's no square rooting on this one because I already know what my geometric mean is. When I go ahead and I multiply this one together, I get 4x is equal to 100, so x is equal to 25. 10 is the geometric mean of 4 and 25. I know that this perimeter of this shape is 56 centimeters. And the ratio of JK and KL is 4 to 3. So JK and KL have a 4 to 3 relationship, but I know that 4 plus 3 plus 4 plus 3 is not going to equal 56. So I'm going to go ahead and put that X in there to figure out what factor was included. My perimeter is equal to twice my length plus twice my width. So my perimeter is equal to twice 4x plus twice 3x. My perimeter is equal to 8x plus 6x. So I have up here 56 is equal to 14x. So that ratio is simplified by a factor of 4. All right. What we want you to do tonight for homework, we want you to practice these problems here, and then you have some more on the back, and then you also have some delta math. So the practice and the delta math. In addition, I want to pass back your Unit 5 tests.